welcome to today's class. So today we'll be taking on remainder and factor theorem. So we have to do this particular topic before we can do partial fraction afterwards and do polynomials and binomial theorem and other things. So today we'll take remainder and factor theorem. So remainder and factor theorem, you have to understand from the simple division that we used to do in order to get like mixed fractions. That's what this problem is actually about. Let me show you what I'm talking about. So now what you have to understand about this at first is that you have to go back to 10 divided by 3. Okay, 10 divided by 3 naturally is 3 whole number 1 over 3. And this can still be written as 3 plus 1 over 3. This is still the same thing with this, and still the same thing with this. So getting this now, you can still do it like this: 3 and 10. Then 3 in 10, 3. Then 3 multiplying 3, that's 9. There's a negative here, it becomes 1. Now this is the remainder. Okay? This here now is called, okay, sorry, this is the remainder. Because this is what is remaining after the division. This is called the divisor. And this is called the quotient. So you can see label it from here that this is this underneath here is divisor, and this is the remainder. So you just have to understand these simple things, and whenever you're doing it, just try to always like write this again, 10 over 3, then divide like this again, so you don't get yourself confused when you see letters like X and A and B and stuff like that. So now I'll just take you on a simple example. Okay, let's take these basic examples. Says find the remainder when 3x cubed plus 6x minus 1 is divided by x minus 3, and find a if x cubed plus ax squared minus x minus 8 is divided by x minus 1. Very basic examples. That's why I taught you it's 10 over 3. That's thing you're going to do is they're asking you to find the remainder when this is divided by this. That means just like 10 over 3. The remainder, this is 3. This is the quotient. You have to find quotient. This is it. 1 over 3. Then this is the remainder. They're asking us to find what will remain after we divide it. So I'm going to divide again the same way I divided this also. So this is x minus 3. You have to note something, that this is a polynomial. So 3x cubed, while dividing we can't just write plus 6x minus 1. You can't write that. You have to understand that there was something here which is x squared before this and this. Because it's a polynomial, we can't just jump to 6x just like that. So let's solve. So this is 3x cubed plus 6x plus 0x squared. Always look at the power. Plus 6x, this is raised to the power 1, that means you've done it well, minus 1. So now we take this, dividing the first one, just that, as simple as that. This dividing this, which is 3x cubed over x, this becomes square. You can learn my indices videos, because I want to be fast in this. So this is 3x squared. So when you multiply, you get 3x cubed you multiply this by this also, you get minus
Yeah.
9x squared. A negative would always be here. So then when you subtract this both, you get 0. Then this minus this, then you get plus 9x squared. Then you get, then we bring these ones down, plus 6x minus 1. Now, this power is still greater than 1, which is here. So we divide again. So x dividing this, you get plus 9x. Then when we multiply it, you get, then when you come down, there will always be a negative here also. And this multiplying this becomes 9x squared. This multiplying this becomes minus 18x. Now, this negative affects everything inside it. So 9x squared minus 9x squared is 0 again. Then 6x minus this becomes positive 24x. And that is that. Then we'll bring this again. Now, this power is still equal with this one. That means it's still possible to get divided again. So we use this to divide this one more time. So this is x dividing this, it remains just positive 24. Then when we multiply, get 24x. Then 24 multiplying 3, negative, that's 52. There's also a negative here also. So this becomes 0, minus 1, minus 52, which is positive 51. So the remainder is simply positive 51. So the remainder is 51 when you divide this. So to let your answer look more beautiful, you can write it like the same way I told you. You can write it like 3x cubed plus 6x minus 1 over, okay, you write the divisor like this. You write x minus 3, which is dividing it. Then you write the quotient, what you got, which is this 3x squared plus 9x, plus 24. Then this, then you write the divisor, which is x minus 3. Then you write the remainder, which is 51. Simple as that. So you just write this as your final answer. But everyone knows this is the remainder. So that's all for that. So let's solve the second example. These are just basic examples. We'll be taking problems concerning this topic. Just two also, then that's all. So I believe you're meant to understand afterwards. Example, find A if x cubed plus ax squared minus x minus 8 is divided by x minus 1. That means that this is a factor of this. That means like when you're actually solving like factorization, when you ask to factorize something, you know that your final answer will be x minus something. Let's say x minus 4 and maybe x minus 3 after you solve a factorial. So for you to actually get what x is, what is usually done is saying x minus 4 equals 0 or x minus 3 equals 0. Then x is now equals 4 and x is now equals 3. Like this is a factorial problem. This is how it's usually done naturally, mathematically. So now we are going to apply the same thing with this because we are told that this is actually a polynomial and this is a factor amongst this polynomial. I mean, they didn't ask us to look for another factor. If you ask to look for another factor, then you are meant to divide it. If you ask to look for maybe the quotient when this is dividing this, you are meant to divide it. But since they're just asking for what A is, you don't need to stress yourself. You just have to simply say okay, that's the topic, meaning and factor theorem. So you just have to simply say x cubed plus ax squared minus x minus 8. So now you write when the factor is x minus 1, then when x minus 1 equals 0, then x is equals 1. So now let's call this equation 1. Now substitute x equals 1 into equation 1, and this. So now x is 1 now into this. This is 1 cube plus a into 1 square minus 1 minus 8. So what happens here? This is also equals 0. So this is 1 plus a minus 9 equals 0. Minus 1 minus 8 is minus 9. Then minus 9 plus 1 is minus 8 equals 0. Then a is equal to 8. Simple as that. Someone else would have stressed themselves to divide and do all of that, but it's a very simple problem. So let's take the exercises.